Hi friends, welcome to the next topic in sensors and transducers. And we already studied what is sensors and transducers. What are the difference between sensors and transducers and the different classifications of sensors. Okay, and today I'm going to just revise the sensors and transducers. Okay, sensor is a device that detects the changes in physical conditions and turns it into a signal which can be measured or recorded. Whereas a transducer uses a transduction principle to convert a specified measurement into a usable output. Okay, a sensor in a sensor there is only a sensor element or sensing element, but in a transducer there is a sensing element and a transduction element. Mm? There are different classification of sensors and transducers. There are active transducers, passive transducers, then primary transducer, secondary transducer. There are different classifications of transducers, and we study some of the classifications of transducers. Okay, on the method used for the transduction, the transducers can be inductor transducers, resistive transducers, and capacitive transducers. In this video, I am going to teach you what is resistive transducers. Okay, resistant transducers. The transducers whose resistance varies because of the environmental effects such as such type of transducers is known as resistive transducers. The changes in resistance is measured by the AC or DC measuring devices. The resistive transducer is used for measuring the physical quantities like temperature, displacement, variations, etc. The measurement of the physical quantity is quite difficult, and the resistance transducers convert the physical quantities into variable resistance, which is easily measured by the meter. The process of variation in resistance is widely used in the industrial applications. The resistive transducers work as the primary transducers as well as secondary transducers. In primary transducers, the changes the physical quantity into mechanical signal, and the secondary transducers directly transform it into an electrical signal. Okay, and the main advantages of resistive transducers are both AC and DC current or voltage is appropriate for the measurement of variable resistance, and the resistive transducers gives the fast response. It is available in various sizes and having high range of resistance. Okay, now we can study the working principle of resistive transducers. The resistive transducer element works on the principle that the resistance of the element is directly proportional to the length of the conductor and inversely proportional to the area of the conductor. Now we can represent this with the equation R is equal to rho L by A. Here A is the cross-sectional area of the conductor in meter, R is the resistance in ohms, and L is the length of the conductor in meter square, and rho is the resistivity of the conductor in material in ohm meter. With this equation, we can say that the resistance is directly proportional to L, that is the length of the conductor or the length of the wire, and the resistance is inversely proportional to the area of cross section. Okay, and with this principle, we can make different transducers like potentiometer, strain gauge, etc. And this is the working principle of our resistive transducer. And different applications of resistive transducers are potentiometer, strain gauge, resistant thermometer, thermistors, etc. And first is potentiometer. The translation and rotatory potentiometers are the examples of resistive transducers. The resistance of their conductor varies with the variation in their length, which is used for the measurement of displacement. Next is strain gauge. The resistance of their semiconductor material changes when the strain occurs on it. This property of metals is used for the measurement of the pressure, force, displacement, etc. Then resistance thermometer. The resistance of the metal changes because of the changes in temperature. This property of conductor is used for measuring the temperature. Last one is thermistor. It works on the principle that the temperature coefficient of the thermistor material varies with the temperature. The thermistor has the negative temperature coefficient, and the negative temperature coefficient means the temperature is inversely proportional to resistance. Okay, in this video I'm just give a introduction of resistance transducer and working principle of the resistance transducer and the different applications of the transducer. In the next video, we can study in detail what is potentiometer, strain gauge, etc. Okay, thank you for watching.